So, this July it'll be 19 years for me at Microsoft. I started in '88 when we hadn't even shipped OS2 yet. And the reason I'm still here after all this time is because there's an incredible passion for technology in this company, right? People in this company just love computers and love technology and love what it can do for people, right? And I do too, right? And that's one of the big things that TechFest is really about. Is the whole company geeks out on this event, all the way up to Bill and Steve, because we're here because we're really passionate about technology and what it can do, and that's why I love coming here. There's a lot of things that technology could do, particularly like databases of things like jobs and government services, that we'd like to make available to everybody, including people who can't read, right? So wow, that's a hard problem. How do you create computer interfaces for people who can't read?
So this little application is a client, and it allows people to sign up. So this is my username list, right? So I would choose myself. This is the password. So a password is just a sequence of images rather than your typed out password. So, and then if I get it right, I get to go into my inbox. So here I have some samples of messages that my friends have sent me. So Aishwarya here sent me a text message, a typical message. Vibor has sent a video message. Someone else has sent me an audio message. So here is what a video message looks like. At the end of the message, I get to reply in any mode that I'd like to reply in. So let's say I want to reply in a video. So I click on record and immediately, like, hi, whatever, this is my message, it's already recording. And it's just as simple. This is my contact list. My address book is just a series of images. And I can select multiple people and then click on send, and it's already out there. Yeah, and she's my assistant. Whenever I get confused about what I'm supposed to do, I just need to mouse over, and there's like an audio assistant. She tells me what to do. Yeah, she tells me like, hey, these are the messages that you got. If you click on this, you can create a message, and like now you can choose. Would you like to make a, ink message? So you can then draw out a message and then send it out to people and things like that.
Are you actually using this with real people yet?
Yes, we are actually. So we're running usability tests, and so far they've been extremely positive. What we've discovered is that people love making ink messages, like they love drawing and things like that, and they love receiving video and audio messages. And we've actually enabled even for text messages to be read, so it's text-to-speech, which happens automatically. So the entire experience is really simplified. It's very front-end. I don't need to know how to make a video, or I don't need to know how to do anything. It's all right here for me. And the hope is like it's basically a client, so anyone could just download it off the web, and like it interfaces with Hotmail. So it's basically what is going out is an email message with a video attachment or an audio attachment, so it can interface with any other mailing.
There's hundreds of millions, if not billions, of people who don't know how to read, right? So, and if we really want, there's some things that technologies can do to actually improve the quality of life for people everywhere. Right? There's some things that can't. We have to be realistic about that. But they're real opportunities, and it's research like this that will help us figure those out.
You're showing.
So this is kind of cool in a physics geeky sort of way, right? This is my walking route color-coded by the total number of G-forces.
Turn your badge over to
Sorry. Total number of G-forces that my body is under. And what you see is this is 1.2 G-forces up to 1.455 G-forces. Now, 1 G-force is always due to gravity pulling you down. So the remainder is my motion. Now, like I said, cool in a physics geek sort of way for this little demo. But imagine I'm searching for mountain biking routes. Suddenly, the amount of G-forces, that acceleration, is an incredibly important factor in determining, how aggro is this on a scale of 1 to 5 or whatever scale you want to use.
So could you send a bunch of mountain bikers all over the place with this device on it and map out certain trails?
That is exactly what we're going to do. In fact, we're just getting to the point in the manufacture of these little devices where we can order a bunch more of them, and we're going to give them out to people and say, use it, try it, let us know what you think.
And what is the device like?
Well, this is our current hardware, not necessarily our ultimate end-user device, but it's a little black box of sensors. And it's got an accelerometer, 3-axis accelerometer, it's got a heart rate monitor, a temperature sensor, a GPS, a Bluetooth, and a cell phone battery in it. Yep.
So I'm showing a couple projects on wearable physiological monitoring on your smartphone. So the first project is to monitor people when they're sleeping and automatically detect sleep apnea events. So if you want to put this on, I have a similar box to a Scott's box, but my box has a 3-axis accelerometer. It has an oximeter, which is this sensor here. It has a temperature sensor and a pressure sensor. Usually you wear this when you're sleeping, and usually you put it on your toe, and then this little box, I have a little pouch, and you put it around your ankle, and you just go to sleep with it. You turn on your phone. It's just telling me that you got connected. So this is your heart rate right now. It's 90. This is your blood oxygen level. And this is what is called the plethysmographic signal. You can extract systolic blood pressure and respiration rate from that signal. All the data is being sent wirelessly to the phone via Bluetooth, and the phone is analyzing the data in real time on top of storing the data, and it is detecting sleep apnea events in real time. So when you wake up in the morning, you can ask the phone how well you slept, and it gives you here a summary. Now there's nothing because you didn't go to sleep, but it gives you a summary of how many apnea events you had and the severity of the events. It also has other sensors, as I mentioned. So I have the 3-axis accelerometer data, so the phone knows whether you went to the bathroom, or it knows if you have the restless leg syndrome, where you move your legs a lot when you're sleeping. It also has the temperature and the altitude. So another project that I'm going to be doing is with pilots. So this is this project, and I have done a lot of sleep studies with the project. So if you want, I can show you a couple graphs of people with apnea and without apnea, so you can see the difference. This is the blood oxygen for a person without apnea. This is the heart rate. And the interesting thing is that you can start identifying even sleep stages. So this corresponds to deep sleep, and this corresponds to REM sleep. And this is the detection by the algorithm, and there's nothing. This is a case of mild apnea, and the blood oxygen starts going down, the heart rate goes up, trying to compensate for it, but usually it can't, and then the person gasps. And this is the detection by the phone. And this is a case of pretty severe apnea. The interesting thing is, like, these were volunteers from one of my studies, and many of them had never gone to a sleep center or to a doctor. So hopefully after doing this study, they decided to go.